I'm going to discuss again the question answer section, question answer series, heat transfer chapter. So in my last video, I discussed about this true and false objective type questions, that is true and false. This fill in the blanks, then choose the correct answer, and then correct the incorrect answers. So questions rather. So today I'll start with the short and long question and answers. What is matter and what is it composed of? Anything that has mass and volume is matter, and it is composed of tiny particles called molecules. Now name the three states of matter and distinguish them on the basis of their volume, shape, volume and shape. Okay, the three states of matters are solid, liquid, and gas. We know it. Then the solids have a definite shape, liquids have no definite shape, gases also do not have any definite shape. Solids have a definite volume, liquids have a definite volume, but gases do not have any definite volume. Now distinguish between liquid and vapor or gas states of matter on the basis of the following factors, that is intermolecular separation, intermolecular force, kinetic energy, and arrangement of molecules. Now first is arrangement of molecules. Liquid molecules are closely packed, vapor molecules are very loosely packed. Then intermolecular separation, liquid molecules are least separated, vapor molecules are maximum separated. Then liquid molecules, intermolecular force in case of liquid molecules, they have maximum intermolecular force, um, but less than the solid. But in vapors, they have least intermolecular force. Okay. Then in case of liquid, the kinetic energy of the molecules, they have least energy, whereas in case of vapor, it has maximum kinetic energy. Next is what is evaporation, and explain it on the basis of molecular motion. Now evaporation is change of liquid into its vapor at all temperature from its surface. Okay, that is known as evaporation. Now on the basis of molecular motion, the explanation is like that the force of attraction between the molecules of the liquid is much less than compared to the solid. So the attractive forces between the liquid molecules is not so strong to keep them in the fixed position like the solid. Thus, the liquid molecules can move throughout the liquid. The average speed of the liquid molecules are more than that of the solid. Okay. So the average speed is more of the liquid molecules, they are more. Their intermolecular force of attraction is less than the solid, and intermolecular spaces are also more than the solid. So the relative distance between the liquid molecules and the direction of their motion is found to be totally irregular. Okay. When a moving molecule of a liquid reaches the surface, it is pulled inside by the cohesive force. When they reach to the surface, the liquid molecules, while moving, because the liquid molecules always move, they change their position. So, when they reach the surface, they are pulled inside by the cohesive force of the surrounding liquid molecules, as there are no molecules on the other side of the surface. On the other side of the surface, there are no molecules, no liquid molecules. So, the liquid molecules are on the downside, so they are pulling the surface molecules inside. Okay, not allowed to leave the surface, and so a liquid has a definite volume. Okay, but in case of gas, the intermolecular space is much more than in solids or liquids. Okay, the intermolecular force of attraction is negligible, and the molecules are free to move about over the entire space available, and therefore the gases have neither a fixed shape nor a fixed volume. In case of liquid, the moving molecules collide with each other, and in doing so, some molecules gain more energy, more kinetic energy. That is, their average kinetic energy increases while colliding, and when they reach to the surface of the liquid, some molecules they lose energy, and some molecules they gain energy. The molecules which gain energy, they that is, they have higher kinetic energy though than the liquid inside. The liquid and the molecules which lose energy, they remain inside. The other molecules which gain energy than the inside molecules, they evaporate. They start changing the state. They leave the surface of the liquid. Okay. During this swap, the surface molecules, which have the sufficient kinetic energy, they act against this sufficient kinetic energy. They work against the force of attraction on them due to the inside molecules and escape out from the surface into the space in the form of vapor. Okay, these escaping molecules from the vapor of the liquid form the vapor of the liquid. Okay, this process continues all over the liquid till all the liquid evaporates. All over the liquid means, till the liquid, all of the liquid evaporates. Okay, this process continues, and that is the evaporation process which is taking place. Okay, then do all the molecules of the liquid take part in the evaporation? If not, explain your answer. Only the surface molecules take part in the evaporation process. The moving molecules of the liquid which have sufficient kinetic energy reach to the surface, and those moving molecules lose energy, remain inside the liquid. This happens as the moving molecules collide with each other, and the surface molecules, they have higher kinetic energy which work against the this coercive force. Okay, and they leave those inside the liquid, and they leave the surface molecules the surface of the liquid in the form of vapor. Okay, no heat is supplied to a liquid during evaporation. How does then the liquid changes into vapor? The liquid draws heat from its surroundings and changes into its vapor. Then comment on the statement that evaporation is a surface phenomena. Evaporation is a surface phenomena. We know it. Why? Because during this process, the molecules of the surface have higher kinetic energy than the inner molecules, and they dissipate into the air. Okay, as the sufficient kinetic energy which overcome the coercive force due to the inner molecules. Okay, that is, they escape from the topmost layer of the air. So evaporation takes place only from the surface of the liquid and not from inside. Now, why is cooling produced when a liquid evaporates? Because in this process of evaporation, what happens? The liquid changes into vapor or rather you can say the liquid draws heat from the surroundings and changes into vapor. Okay, if there is no from the surroundings, if there is no supply of heat, okay, no external supply of heat, then it absorbs the heat from the surroundings, draws the heat from the surroundings, and get evaporated. So in turn, it produces a cooling effect around the surroundings. Okay, now give reason for the increase in rate of evaporation of the liquid when air is blown above the liquid. Surface area of the liquid is increased and temperature of the liquid is increased. When air is blown above the liquid, the rate of evaporation increases. It is so because the blowing air takes away the liquid molecules out of the surface with it. And to take their place, the other molecules from the inner surface of the liquid, they move towards the surface of the liquid, and in turn this process goes on till all the liquid evaporates. Now, on increasing the surface area of the liquid, exposed part of the liquid, okay, the rate of evaporation increases. It's because that on increasing the area of the surface, the number of molecules which will evaporate, that more of the molecules are exposed to the surface. Okay, and so more of the molecules will get evaporated. The rate of evaporation increases with the increase in temperature of the liquid. It is because with the increase in temperature, the energy of the molecules increases, and this energy, that is their average kinetic energy, increases, which acts against, or rather which overcomes, the coercive force of the molecules of the inner surface. Okay, and therefore they escape out into the space from the surface. So more and more molecules come to the surface to take their place, and this goes on this rate, and therefore the rate of evaporation increases. Now what is boiling, and explain it on the basis of the molecular motion. The change from the liquid state to the gaseous state or vapor state on heating at a constant temperature is known as boiling. When a certain liquid is heated, it rapidly changes to vapor from all of its parts, which is indicated by bubbles. See, in evaporation, the change of state, that is from liquid to gas, was only from the surface. But in case of boiling, it's a rapid process, and it takes the whole container where the boiling is taking place. Whole of the liquid takes part in this process. When the liquid is heated, the average kinetic energy of the molecules sufficiently increases, and so that it can work against the cohesive force of the other molecules, and then the molecules start leaving the liquid from the container throughout the vessel. Okay. Now, why does bubbles appear when a liquid is heated? On heating a liquid, when a liquid is heated, then it starts changing into vapor state at the place where it is being heated very rapidly. Okay, when this change, that is from liquid to gas, this change of state on heating, this process occurs very rapidly, and this conversion of the liquid to gas appears in the form of bubbles. Okay. Now, what is the change in average kinetic energy of the molecules of the liquid during boiling at its boiling point? Average kinetic energy is the measure of the temperature of the body. So when temperature of the body increases, the average kinetic energy of the same, that is of the body, that increases, and vice versa. And therefore the boiling point, at boiling point, the average kinetic energy increases. So with that, I stop here. I'll continue with the rest of the question answers in my next video. Please go through this. Hope you are liking the videos. So press the like button, and also do subscribe, so that I can produce you some more interesting videos which will help you in your studies. Okay, and I'll be launching a website soon which will contain more information about your subject and also different other subjects. Okay, and some interesting facts are also there. So please wait for that, and I'll thank you for watching this video. Thank you.